Hello, today we are going to continue following the tutorial Introduction to Qt QML 54 parts from the KDAB YouTube channel. So this is a YouTube playlist, 54 parts, 10 hours and a half. And we're at the hour 1 and 28 minutes. We were last talking about transformations, the transformation using rotation. So rotation is a real, so a float point number, which is actual 0 to 360. And where are you? We have a transform origin. So by pressing F1, I go to the documentation, I select, so I put the mouse cursor on transform origin. I press F1 to go to the documentation and then escape to return back to the source code and close the documentation. Okay, so transform origin is an enumeration. And has the possible values: top left, top right, right, center left, bottom, bottom right. So item dot something. The default is item dot center. Okay. But if you want to rotate using another transform origin point, then you are free to do more types of transformations than what we showed until now, which is rotation and scale and opacity. And we can go further than that. So these are the preset predefined transformations. There also exist custom transformations with the transform property. So we have the possibilities rotation, scale, translate, and matrix 4x4, where the property transform is a property of the item and is a list of transform. So let's look at that. So transform, a list of transform. Could be rotation, scale, translate, or matrix 4x4. So these are types. And this is a property. Okay, let's look at this thing, this example. Okay, so this does a rectangle which inherits from item as a width and a height. Otherwise, these are the default values for width and height are because the rectangle is the root element of the top level element. It gets its default width and height from the actual X11 window. and then it says color blue. So you can see how resizing the X11 window actually resizes the width and height of the rectangle, although it's transformed. So the rectangle is actually blue, has a width and a height. And then there's the property transform, which again is inherited from item. Okay, and the rectangle inherits from item. Inherits item in here. Okay, and this is a list of transform, and one such transform is rotation. Okay, so there's an origin X and origin Y and angle. Okay, there's math behind it, so if you really need more custom transformations, then you're going to be reading into the math and all of the possible transformations. So all of the 4 possible types that you could use in here, which again are rotation, scale, translate, and matrix 4x4. Unknown component matrix 4x4. See if this thing runs. Matrix 4x4 is not a type. I should import QtQuick, which I did. Okay, so that's about it with transforms. And now we're at the chapter where we talk about how to lay out items. So item is the base type in QML. We can lay out in 4 ways. The simplest way, the way that we have used until now, is manual layout, so manual positioning with the properties X, Y, width, and height. There's all sorts of disadvantages to computing X, Y, width, and height if you have multiple items on your QML window. And then there's at least three layout managers, which is anchor layout. So this is the property anchors. Then there's positioners with column, row, grid, and QtQuick controls layouts. Next, we're going to go to the anchor layout. Okay, so this is an example QML file that uses anchors.write. So we have 2 rectangles. One is the child of the other, so the child can access the parent via the ID. So the first object of type rectangle has the ID background. The second one does not have an ID. And we say anchors.write is background.something, because we want to glue the right hand side of the green rectangle to the right hand side of the light blue rectangle. So let's run it and see what it's doing. So it gives the error that you cannot anchor to a null item in the sense that this is this is null or this is null. So the way to do it is to go background dot right, so no anchors here. Let's run it. And now it does the correct thing. So anchors means the current object. So anchors is a property of the current object. So the current object needs to have one of its elements such as left, right, top, bottom, or center or fill be glued to a coordinate of another item. So we can make for instance, the right margin of the rectangle of the green one be glued to the right margin of the right side of the parent rectangle, which is light blue. This is the syntax. Anchors.right is bound to background.right. Okay, let's look at the documentation. So this thing first. Margins. Okay, so the bottom margin, left margin, right margin, and top margin. Properties. No, this is Qt charts. Okay, so it's in a different place. No, it's I'm not exactly sure what this thing is. I don't see it in the help. So we don't use Qt Quick 3D. This is not a key navigation. We don't use Qt charts. This is for graphs. This is for 3D. And these are for C++, not for QML. Okay, let's look at anchors. No documentation available for anchors. F1 item. I'm going to guess that item has anchors. So this thing. Anchors right, which is boundable, which is of type anchor line. So anchors.top is of type anchor line. Anchors.right, anchor line, anchors. Where are you? Bottom, so top and bottom, left and right. And in addition, there's also baseline, horizontal center, and vertical center. Okay, don't we have help for anchor line? So you can align two items. For instance, in here there's an image and a text. They are anchored. The horizontal center of the image is on the same line as the horizontal center of the text. But this is anchors left and image right. So these two are glued together. The left part of the left property of the text and the right property, the x plus width property of the image. But then there's also a left margin of 5 defined. So then the text moves 5 pixels to the right. The default value of anchors is undefined. You can anchor an item to siblings, which means that the other item has the same parent. So the two items that you're anchoring one to the other have the same parent, or a child to its immediate parent. Okay. So it's a way to glue items together. Let's paint this thing. Okay, so we have item A and item B. So you lay out item A however you want, and then you can tell item B anchors.left is A dot right. Okay, let's do that. So we have two rectangles. Anchors.left. Okay, so this is what we wanted, to have two rectangles glued together, one in the right hand side of the other. So similarly, you can glue them one on top of the other. That would be anchors dot top, green rectangle dot bottom. Like this. Or you can make the red rectangle inside of the green rectangle. Make this smaller. Okay, and as we see, the Y property is overridden by anchors, so there's no need for the Y property. Okay, so we made the rectangle that's red smaller, and now we're going to place the red rectangle inside of the green rectangle. So anchors dot left, green rectangle dot left. Yeah, so the left part of the two rectangles are glued together, have the same value, which is x is 0. Okay, and we can put another glue where we anchor the tops of the red and the green rectangle. So we go anchors. We wait a bit for the auto completion to work. So tab, and now we go top auto completion with the tab key on the keyboard, and green rectangle dot top. Control S, and let's run this thing. Okay, so there's many anchors in the red rectangle, but all have the value undefined except two, anchors left and anchors top. So anchors top says that the top, so the top sides of the two rectangles are at the same y on the OY axis, and the left sides of the two rectangles are on the same x, which is 0. And we can go even further. We can use some more anchors, like we can make the bottom of the red rectangle be glued to the bottom of the green rectangle. Okay, what did this do is so the QML engine needs to display this QML file. It sees a rectangle, instantiates it, so this is a type, gives it the ID background. 300 and 100 are just some initial values that are used in order to decide the dimensions of the X11 window, so 300 by 100. And then the background color is light blue. If we resize the window, the actual rectangle resizes. So that's why we have light blue everywhere in the window. Then there's two rectangles. The first one has a y of 25, so this is this gap, so 0 y axis. And then it has a height and a width, so it's a square 50 by 50 pixels, which, having a y, a height, and a width, it knows exactly how to position. So x0, y 25, height 50, width 50. So it knows all four edges. Okay, so the top left one, the left right top one, the bottom right one, and the left bottom one. Then the third rectangle. We know that its background color is red. We know its initial height, which is 25, initial width, which is 25, and then it needs to interpret the anchors. So the anchors say that the left side of this rectangle should be glued to the left side of the green rectangle, so both are at x is 0, and then anchors dot top of the, so the two rectangles red and green should have the same top, which means the same y property, which is the property of the green rectangle, which is 25, and then anchors dot bottom, so both green and red rectangle should have the same bottom, which we know the bottom of the green rectangle, it's 25 plus 50, so it's 75 on the OY axis. So this point here. So although the red rectangle specified a height of 25 because of the anchors, its actual height is 50. So the same height as the green rectangle. Okay. But because we did not specify any other width for the red rectangle, it kept its initial width, which is 25. Can go even more and add the missing anchor, which is anchors.right. Green rectangle.right. And now this is overridden by top and bottom anchors, and width is overridden by the anchors left and anchors right. You cannot see the green rectangle anymore. We saw that there's anchors for some padding. Let's see what this thing does. So the green rectangle has its usual x, y, width and height, but the red rectangle, because it specifies a margin of 5, is smaller when displayed on the monitor, is 5 pixels smaller all around. So you can see 5 pixels of the green rectangle on the left hand side, top, right hand side and bottom of the red rectangle. Okay, now let's see what happens if the rectangle that we use as the anchor value changes. So we know that this rectangle will resize when we resize the window. So how about if we anchor the green rectangle right to the background right? So again, anchors.right is a binding, not an actual literal. Whenever background.right changes, and it changes whenever you resize the X11 window, then the anchors.write for the green rectangle will be recomputed, and that will also trigger the recomputing of anchors.write for the red rectangle, which will then recompute the x and the x of the red rectangle. Okay, so changing the width of the background rectangle changes the x of the green rectangle, which then changes the x of the red rectangle. Next, these anchors.left and anchors.top, anchors.bottom, anchors.right, anchors.margin, all of these are actually configuring the property anchors of the item. Where are you? So the type item with an uppercase I, QML type, has a property named anchors. And then inside anchors, we can do additional settings. So individual ones like anchors.margin, but we can also specify anchors just one and give it the value of a JSON style object. So back to edit, we can have this thing. Anchors. Control S. So let's see how it looks like. So it says invalid property assignment anchors is a read-only property. So we're not allowed to use colon. So this says that the moment when you instantiate this object, anchors, which is a read-only property, so probably only settable via the constructor at object construction time, is going to be passed this JSON object, JSON-like object. So it uses JavaScript notation. Okay, and as we saw, it works identically. Next, we'll look at the vertical center anchor. So we have a bigger rectangle, a smaller rectangle, and we're going to set the vertical center. So anchors, vertical center, green rectangle, vertical center. The rest we can not have. Control S, let's run. Vertical center, what did I just do? This is a horizontal line and this is the vertical center, okay? So I meant the horizontal center. Let's do that. Or no, let's have both. Okay. So there's a shortcut for vertical center plus horizontal center, like I'm using them here, which is center in. Okay. Okay, then again in the documentation says that you can anchor this rectangle to this rectangle because they're siblings, they have the same parent, but you can also anchor this item to its immediate parent, and for that we have this special identifier which is called parent. So let's use it. We go anchors, center in, and then in here we might have background because that's the ID of the parent. So this rectangle has one parent with ID background. Okay. Or we could not use this ID at all, not even define it. And then we have the special identifier, which is parent. Okay. So the parent is a property of item. So in the documentation of the item QML type, we have the parent, which is a property of type item. And we've bound anchors.center in to this this dot property. Let's see if this thing even works. It totally does work. So this dot, this being the current instance of rectangle, the object, and this is the property. Okay, and besides center in, there's also fill. So now the green rectangle covers the entirety of the light blue rectangle, and we cannot see the light blue color anymore. If you want to see it, you need to use anchors dot margins. And now we can see some of the light blue rectangle. Okay, so that's about it about anchors. The next thing that we're going to look at is when you glue items together. you're creating bindings. So as in this case, the y is not 25, but it's either 0 or 5 because of these bindings. So whenever you have items that have x, y, width and height properties bound via anchors or other layout techniques to other items, it's extremely easy to create a binding loop. Let's actually decide what's the x, y, width and height of the green rectangle when it has anchors fill parent and anchors margin 5. We save, we run, and now we're going to inspect this application in the GammaRay application. So it's QML, the executable that can display QML files, and then x-expressions.qml, which is our current file that we're editing. So the process with process ID 6503. Attach. And now we have, let's look at the source code. It says we have 4 cute, quick objects. There's 3 instances of the rectangle and one which is a quick root item. So it's the QML type slash and the C++ name quick root item. Okay, so the first rectangle, which is a parent of the other 2 rectangles, is the rectangle that has color light blue, and this should have the size of the window. So let's look at its property values. Width 426, not 300. Width 307, not 300. And the height is 204, not 100. Okay, so we can see that as we resize the X11 window, the width and height of the parent rectangle, the light blue rectangle, changes. Okay, so this is definitely the light blue rectangle, and then there's a green rectangle. IDs, when we give to the object an ID, we can see it in here in the GammaRay quick scenes object column. So it says green rectangle, whereas the other object, which is anonymous, does not have an ID, goes by this 0xF7FE ID. So we know for sure that the first one is the green rectangle and it's this one. And this is what we're interested in. What, for the green rectangle, what are the x and y? If they're 5, 5, then anchors.margins actually affects the x and the y of a rectangle. So the x and y are both 5, which tells us that the width and height are the width of the parent minus 2 times 5. So in this case, 290 is the width of the green rectangle. Yes. And the height, again, is the height of the parent, which is still 100. I didn't resize the X11 window. Minus 2 times 5, which is 10, so 90. And we can see it in here. Okay, and the red rectangle has its initial width and height, and X and Y are given by centered in. So width is still 25, height is still 25, and X and Y are computed because of this binding. Okay, so previously in all of the examples, we either bound one rectangle to its sibling. So we bound a property of a rectangle to the properties of rectangle that was sibling, or we had bindings in the child towards the parent. So we had anchors.fill and then parent. So the right hand side of the property, the binding, comes from the immediate parent or from a sibling. With this discipline, it's kind of impossible to create a binding loop. But then so if you only assign to children values from the parent, then you're not going to be able to do a binding loop, because in order to create a binding loop, you also need to assign to the parent right-hand side that comes from the child. So anchors.fill parent means that rectangle.width is parent.width, but then parent.width is child.width, and child.width is parent.width, and parent.width is child.width. So this is a binding loop. It's an infinite loop when trying to compute any of the two widths. So the property width of the black rectangle and the property width of the green rectangle. So let's run this source code and see. So indeed it says it found a binding loop for width. So when it tried to compute the width of the parent, but we also have another binding loop for the height, because the height is in the same spot as the width. So the height of the parent is child.height, but then the height of the child is the height of the parent minus 2 times the margin, which is 5 minus 10. But then the height of the parent is the child.height, etc. Okay. Qt Creator gives us navigation to the error. to lines 5 or 6 in the correct file. We should fix all of the binding loops that we have in our QML applications. Let's see how we can do this. Okay, so let's replace the second rectangle with an image, which has a source. I've just created a 200 by 200 pixel image. Okay, it looks like this. I've created the file 200x200.png in the same directory as the QML file that I'm working on, which is called ax-expressions.qml. And we still have the binding loop because the parent's width is the child's width, and the child's width is the parent's width minus 10. Let's see how it looks like if we run it. It's like this. Okay, so we can resize the X11 window, which will resize the rectangle, which will resize the image. I'm not sure if that's the correct thing to do, because again, we're inside of an infinite loop. So it might be that the QML engine has seen the binding loop, has not entered the infinite loop, and it's doing one of the possible things. So it did a political decision. Let's do as if the developer had written this other QML instead of the QML that the user has actually written. So basically, it's not evaluating this QML file, but a slightly different one, which doesn't have a binding loop, because we can see that it actually works perfectly, does not create an infinite loop in the sense that it doesn't use the entirety of my CPUs, and it does logically, and the application is stable. It does the illogical thing that could be done in this situation, which is to have the X11 window resizable, have the rectangle bound to the X11 window, and have the image bound to the rectangle. So basically it's kind of like ignoring these two. Now we do not have the binding loop, but this is not what we actually wanted. So this is what I guess that QML engine does. It comments out lines 5 and 6, and then it interprets the QML file again after it detected the binding loops. Because it for sure did not comment out these two lines. So this is totally not the result that we actually see, which also eliminates the two binding loops. Okay. But what we actually wanted to do in this QML file is the following. We wanted the rectangle size to follow the X11 Windows size, but we wanted the source of the image to be respected, at least initially. So we know that this image is 200 by 200 pixels and is a PNG file, which means that this object has not a width and a height, but an implicit width and implicit height, which are the ones from the image. So if we go like this, we can see the implicit height, implicit width of the image. And since height and width is not specified anywhere, then the image.width is equals to image.initial width, and image.height is equals to image.initial height. We can see this thing like this. So width is this dot initial. Okay. Or just initial width. Initial width is not defined. Okay, then we use this. And the same for height. Okay. So these are the default values for width and height, the initial width and the initial height. If you do not specify them, then that's what you get. So what we actually wanted was the behavior that the QML engine actually has. This one. But we also wanted to start, so the initial size of the X11 window to be 200 by 200. That's all that we actually wanted. Which means that this image has the size 200 by 200 pixels. This object has initial width and initial height 200. And we also want the rectangle to have initial width, initial height 200. And then we also want the X11 window to have that initial width and height. So we do that with initial. Width and initial height. Non-existing property initial height. Okay, not initial width and height, but implicit. This is the problem if we do not actually use the code completion. And we do not look at the documentation. Okay, so now the size of the image is 200 by 200. The size of the object of type QML image is 200 by 200. The size of the black rectangle is 200 by 200, and the size of the X11 window is 200 by 200. And then we can resize it freely, which means that the size of the X11 window changes, which changes the size of the object of type rectangle with color black, which, because of anchor's fill parent and anchor's margin, will change the XY width and height of the image. Okay. Just a second, let me look at these things. Interesting. And now it works, even without this. So we've seen previously that we can use the value of a property of the current object for right-hand sides in a property binding. Okay, so we've exited the binding loop for width and height by actually specifying what the initial intention of the QML file was. Okay. Okay, let's go back to the initial state where we have the binding loop. Okay, we don't need this. Control S, and let's run it again. So we see we have binding loops for property width and height. We know why they are there, because in here we specify height of the child to be applied to the parent, and then in here, these two, we specify that the height of the child is the height of the parent minus 10. But because anchors.fill and anchors.margins, all that these two do is edit x, y, width, and height of the current image, the current object, we might understand better why the binding loop for height happens if we actually expand these two to what they actually do, which is assigning values to x, y, width, and height. So let's do that. So anchors fill parent means that the height is the height of the parent And 5 margin means 5 pixels on the top and 5 pixels on the bottom. That's minus 2 times 5. Okay, and the same for width. Two times 5 Ctrl S. Let's run this. And it's wrong because when you go anchors fill parent, you also must specify X and Y. So X is 0 and Y is 0 to have the same X and Y as the parent. But then anchors margin 5 means that there's 5 pixels in the black rectangle on the OX axis, and only then the image starts. So there's a 5 on the OX axis and 5 on the OY axis. Okay, we can see the same error, binding loop or a property with the exact same thing. And now we see more plainly what is the infinite, where is the infinite loop. So width of parent is child.width, and child.width is the width of the parent minus 10. Okay, next is gradients. So at least the QML type rectangle has a public property named gradient. So we can see that it's on the rectangle QML type. I press F1, takes me to the property named gradient, and the property is a var, which is a var QML value type, a generic property type, the equivalent of a regular JavaScript variable. Can store numbers, strings, objects, arrays, and functions. Okay. And we actually put in there the object gradient with several gradient stops. So we can have 2 gradient stops, red, green, and blue, which means that at Y position 0, the color is green, and at the bottom of the rectangle, the color is blue, and the color varies from green to blue anywhere else on the 0Y axis. Okay. We can have more than 2 stops. We can have an intermediate one. Let's say at 25%. Color red. Because we don't use any X and any size in pixels. So the rectangle gets its size from the X11 window because it's the top level QML item. and then the gradient stops go from 0 to 1, and they're floats. Then this 25% 0.25 gets recomputed while I resize the X11 window vertically, while I change the height of the window. Okay, this artifact, this gradient does not look okay to me because it has lines in it, which I can see. There's even rectangles that I can see in here. So this gradient does not look too good to me. Okay, then as it says in the documentation, you can not have a gradient that goes left to right, just one that goes top to bottom, but you can use the transformation of type rotation to transform this thing into a left to right gradient. So we rotated 90 degrees clockwise. So yeah, that's what we expected. If you want a diagonal gradient, then we need to rotate to 45%. Let's actually look using GammaRay at this thing. So the QQuick root item has the size 400 by 400. I didn't resize the X11 window. The QQuick rectangle has the same width and height, so 400 and 400. The X and Y is the original one, which is 0 and 0. So the size of the rectangle is identical to the size of the X11 window. But still, we can see that corners of the rectangle exit the X11 window in 4 places. Why is that? Because transformations are only about the way pixels are presented on the screen. They're not about X, Y, width, and height. So in there, it actually, in the background, there's a Q matrix 4x4 transformation of type diagonal. Okay, so next up, we might want to make it in such that we don't see these 4 white triangles, such that the gradient fills the entirety of the X11 window. For that, we can use another transform, which is the transform of type scale. And now we need to compute the scale, because if we go, 4, then our gradient will not start at green and end at blue, because the green and the blue will be completely out of the X11 window. Let's see exactly. So the gradient actually, so we have scaling 4 times and rotation 45%. So the rectangle is presented like this. This is the top side. This is the bottom side outside of the screen. And this is the left side, this line, invisible line. And this is the right side. So we can actually look with GammaRay and see. We can't actually see because it doesn't show outside of the, or it does. So what's this thing? So this is kind of like the where the rectangle is transformed to. So this line would be the top side, this the right side, this the bottom side, and this the left side. So what we actually need is a scale value such that we don't see the smallest scale right hand side value where we don't see white triangles. So let's go back to the white triangles. So we still have white triangles. Let's make this, 1.3. We still have white rectangles, 1.35. We still 1.4. We still have, so 1.4 dot what? 2. Nope. 1.4.1. And with 1 there's a bit of a white rectangle. So we need more. 4.5. So this is enough, 1.4.1.415. Okay, so now we see the entirety of the gradient. If we went with 1.5, we would see very little of the pure green color or of the pure blue color. Next up is MouseArea. So let's look at this application. It has a rectangle, which is again the size of the X11 window. Inside we have two texts, which text is a label, so not editable, not an input. They have different text, same font size. one is below the other using the y coordinate. And then the entirety of the text object is filled by another layer which is transparent, which is of type MouseArea. So there we say anchors.fillParent, and where we implement events. So we can implement onPressed, onReleased, or other events. Okay, so where can we find the onPressed and onReleased events defined? There's no documentation if you select onPressed and press F1. Nothing for onReleased. Maybe it's on the item. So F1, click on item, and search in here for pressed. General on pressed handler on return pressed. Keys on pressed. So this is the attached property. Which is not this. So it doesn't mention anything, the documentation of the QML type item with an uppercase I, about the events on pressed or on released. Maybe they're on a rectangle. So it just says properties, does not say anything about events, signals, slots, event handlers. Okay, item. So these are the members, and we're searching for pressed or released. No pressed, no released, no on anything. Okay, what about text? These are properties and the first three signals. So text has three events, which are on line laid out, on link activated, and on link hovered. For lines and links. Okay, what about the QML type MouseArea? There's properties, and we see where are you? Signals for on pressed, on released, on mouse wheel, on press and hold, on entered, exited, clicked, double clicked. Okay, let's see the documentation for on pressed. This thing pressed says pressed mouse event mouse. This signal is emitted when there is a mouse press. The mouse parameter provides additional information about the press, X and Y position, which button was pressed. Use the accepted property to control whether this mouse area handles all of the press. The corresponding handler is named onPressed. So for all of the signals, there's a corresponding handler for use inside QML source code, with the on at the start and then the first letter, which is lowercase for pressed, is capitalized for lower uppercase p. Okay. How else can we see the list of properties and the list of signals for a type? We can go in Qt Creator to the design mode, so switch to design mode. And in here, the default mode is switch the active workspace. So the active workspace by default is basic, which has just a number of tool windows. But I'm going to go views all to see all of the tool windows. And I'm just going to close what I do not need. So I do not need transitions, curves, state machine, timeline. Not quick 3D. 2D is enough for me. Then it says QML file contains features which are not supported by Qt Quick Designer at line 11, which is what? This thing. Okay. And then we have the connections, the bindings, and the properties and the backends. So for the text, there's no binding. For the rectangle, no binding. For the mouse area, there's one binding, which is anchors.fill is parent. You can see it in the bindings tool window. It says mouse area, which is the type of the object, and then property anchors.fill, and then the right hand side, which is parent. Okay, the same for the other mouse area. And then what about the event handlers? So we can do Qt style connections with signal and target. But we're not doing this. Instead, we're putting just a plain JavaScript closure function implementation on the right hand side of the onPressed. Probably that's why the forms editor complains that it cannot understand line 11. Okay. These assets are the files in my current directory. These are the open files, this the entire file system. This is the component palette. So there's animated image, border image, flickable, focus scope, image, item, mouse area, rectangle, text, text edit, text input, grid view, list view, path view, for positioners. I do not do any animations. And then there's timer. Let's collapse the animation. And component loader and repeater for if you do your own controls or to represent a list of data. Okay, so let's look at the properties for the individual types. So rectangle inherits everything from item. Let's actually do a top level item to see. Okie dokie. Maybe that's why the forms editor for QML is not enabled by default in Qt Creator. Okay, so the item might have an ID, is of type item, and has x, y width, height, rotation degrees 0. This is a transform. What is this thing? A way to reset the values which are not default. And the binding editor. Okay, so x, y with height, then rotation degrees, then scale degrees. Scale, this is a float, so by default it's 1. Rotation, we can see by default it's 0 degrees clockwise. Z stack, so this is the Z order, the Z property. By default 0, and you go negative or positive to bring it to behind or forward on top of the other QML elements. Okay, I'm not sure what origin does. Visibility, clipping means if the children are going to be visible if you make this component really small. So like this. Okay. Whereas if you don't clip, the children element are not constrained to your width and height. Okay. Go back to where that thing was. Visible. The other properties. Enable focus. What's this? Texture. Source rectangle. I do not know what these things are. Neither this. Okay, next item, rectangle. So rectangle does have anchor component to the top, to the bottom. So this looks like anchors dot with a parent. Yes, so that's it. That's what it is. Okay, so we have anchors dot top equals parent dot top and parent dot bottom and this is vertical center and this is anchors dot vertical center. Okay, and this alignment might be for multi-selection. Let's do that. So mouse area, shift, control click, mouse area. I'm not sure what this is. Okay. So we're at the rectangle. So rectangle has inherited from item the anchors. Okay. Then rectangle, the properties that come from rectangle, not from item, are fill color, border width, radius, and there's also gradient. This thing. Gradient horizontal, gradient vertical. But I'm not sure why I cannot resize this tool window. So the border color cannot have gradients, whereas the background color can have gradients. These gradient controls. Okay, and then text has additional properties from text. So there's the actual string, which is the property text with a lowercase t. Then there's font, font size in pixels or in points, text things, boldness, horizontal and vertical alignment, strike through. Okay, so these are for fonts actually. And then there's text extras, no wrap, elide, render type, mixed case, small caps. Let's look at what it did, small caps thing. So font.capitalization is assigned the value font.small caps. Okay. Wrap mode, text.wrap anywhere. So these combo boxes are created from enums. We can reset all of these. And reset. And you can make a mess quickly out of your QML file. Okay. The list of events. So the events that you can implement are, you can get to them at like this. So you create a new connection and then you look into the combo box for signal handler. So let's go at item. So actually, item has many events, many signals, mainly for that are related to the properties that already exist on the QML type item, such as X, Y, it has X changed, Y changed, then Z order, Z changed, width and height, so width changed and height changed. Then parent changed, rotation and scale changed, so these are for transforms. For transform origin, for visible changed. So most of the properties in the QML class that those properties first appeared, so many QML properties first appeared in the QML type item, that's the place where the signals are actually implemented, and then they are both the properties and signals are inherited from item to rectangle, for instance. And then rectangle adds some extra properties for color and radius and border, and those will probably be accompanied by their respective signals. So let's see if that's the case. Rectangle, and let's remove this thing, add a new signal. The target is the rectangle, which is not named yet. So I need to give it an ID. Main rectangle. Control S to save. And now we theoretically can use the main rectangle target. And we'll need to make a list, a mental list of the signals that exist on item 1, on the signals that exist on main rectangle, and do the difference between those. So color changed. Whereas item 1 does not have on color changed because it doesn't have a background color. So item does not have a background color. The background color is a property of rectangle. So all of these changed signals are about a public property that has its computed value, the instantaneous value changed. So if it's a binding, then the bound value, the bound right hand side does not change, but then the instantaneous value, the value that you can see if you inspect the value with the property with GammaRay, then if that changes, the event will get triggered. Okay, so anchors.top equals is parent.bottom. This means that the rectangle is the rectangle's y, which means the top property, is the same as the item dot y plus height, so the parent's bottom. Let's remove these things because they're a joke. Okay, so if we have width to be the parent width. Okay, so that's the width property of the rectangle is bound to parent.width. And the parent.width will change as we resize the X11 window. Let's run this thing. Okay, and let's start GammaRay and inspect the instantaneous values. So again, if you go with GammaRay and in quick scenes you select one QML object, what you're going to see for X, Y, width and height are instantaneous values. So the values as they are computed, as you would compute them right now. Whereas the binding will not change. So rectangle.width is bound. Rectangle.width is bound. And the instantaneous value is 540. If we shrink the width, then the width of the X11 window will decrease. The width of the item will decrease, and then also the width of the rectangle will decrease. So the instantaneous value is the current value. Instantaneous value of width for the main rectangle is 301, but the width property of main rectangle is actually bound to the parent's width. So all of the properties in QML have three right-hand sides, as it were. There's the default value, which you can get to by where are you? Angle width. So this width you can reset. Okay, so now the width of the rectangle has disappeared from the QML source code. The right-hand side of width is its actual default, whatever that is. Okay, or you can have a right-hand side which is a binding, which is this. And now we can see that size width says that it's a bound. And then there's the instantaneous value as shown if you would inspect the object and you would ask the object using Qt meta object runtime type information, hey, what's your current instantaneous width? And it would say whatever this thing, 301. Okay, so each property has three things: a default value, the value that it was assigned or bound in the QML, and the instantaneous value. Okay. Okay, so we're back to the original version of the example. So there's a rectangle Inside there are two texts which are siblings. The rectangle is the immediate parent of the two texts. Texts are similar to labels, so not editable. Then there's a mouse area that covers the entire text with anchors field parent. And then we have implementation of events that exist on mouse area, do not exist on text, do not exist on rectangle, do not exist on item. So we have three events: on pressed, which means on mouse button down; on released, which means on mouse button up, which is the left mouse button; and another one is on clicked. Okay, and we toggle the boldness of the font. So we go parent, font, bold equals the opposite of parent font bold. Control S. Let's see how it looks like. So the first text on left mouse button down, the text of the parent, the color of the parent becomes green, so the foreground color of the text. On left mouse button up, it reverts back to the default color, which is black. Whereas the second text and mouse area on clicked, which means an entire cycle of left mouse button down, left mouse button up, toggles the boldness of the font of the text. So on click on left mouse button down does not do anything. On mouse button up doesn't do anything, but on the cycle down up, it toggles the boldness. Makes the text either bold or not bold. Okay, so this is the way of using a mouse area with events. So with event implementations, with imperative JavaScript, not with declarative QML. So we have an implementation of the event, which is called onClicked, for the entire mouse area, which mouse area covers the entire, has the exact same x, y, width, and height as the text, the parent QML object. And on the method, on mouse area pressed, we change the color. Okay. So let's have the exact, so this part is going to be the imperative way, so using a event and an event implementation. Okay, so we have a rectangle, two texts, and they do the exact same thing, but using two different techniques. One, it's setting for the text the color green or black, depending if the mouse is down or up. Whereas the other, it sets, so this is using events, event implementations, whereas this one uses a plain property binding. So color is a property of text. We have a binding that says that whenever mouse area, which is, we needed to put an ID for the mouse area that covers the entirety of the text. we named it MouseArea ID MouseArea with a lowercase m. And whenever the property of MouseArea named pressed is true, so it's a Boolean read-only property, if any of the accepted buttons are currently pressed. Okay, and we're using the left mouse button on the left mouse button. So whenever this one is currently pressed, then the color should be green, otherwise the color should be black. This is a ternary operator. Okay, so this is the ternary operator, similar to what we have in C++ and C#. So Boolean condition, then question mark, which is if, then the then, colon, the else. And all of this thing needs to be evaluated as a valid QML color. So green and black are valid QML colors. Let's see it running. So press down the first one, makes parent.color equals green. On released, makes parent.color black. So this part. Whereas the other text label, this one, has this property color and its binding. So when MouseArea is pressed, that's a QML property of the MouseArea, and when the setter for MouseArea pressed is called to set it, in this case, to be press or true, then using observers in the QML machinery and the Qt Quick binding, all of the needed recalculations are triggered. So one of those is this right-hand side. This gets recalculated. This is true, so the ternary will return green. And the instantaneous value of the property text color is now green. When I'm not longer pressing the MouseArea left mouse click button, this property is set to false, which on its setter triggers recomputing of all of the bindings that contain MouseArea.pressed, and now it's false. The ternary will return black, and the color, the instantaneous value of the property color of the text is now black. Green, black. So they behave identically. Okay, but still, if we look at the source code, it only says MouseArea.press, does not say what I pressed. So right click does not trigger MouseArea pressed. Right click not, middle mouse click no, middle mouse click no. So I guess that only button that the MouseArea pressed and on released and on pressed and on clicked gets triggered for is left mouse button click by default. Okay, so this property holds whether any of the accepted buttons are currently pressed, and the accepted buttons has the default cute left button. Okay, and we can add the property accepted buttons to the mouse areas. Run it again, and now right click, right mouse button, click down, and right mouse button up. And the same for the mouse area pressed, and middle click. Okay, and then the sample for mouse area pressed has this text here. So let's see how this thing works. Again, using binding, so a the property text of the text QML object gets bound to mouse area dot pressed buttons. So this is of type mouse buttons read only, contains a bitwise combination of cute left button, which is the mouse left button, which I'm not sure is actually the mouse left button. Maybe it's the mouse left button for right-handed people. Okay, cute right button, cute middle button. And only if the right button is pressed, then it will change the text of the label of the text to right. Otherwise, it will keep the default, which is press me. Let's see how that thing works. So I did not change the first text. The second text is the same if I click on the mouse left button, a mouse middle button, whereas the mouse right click on when the button is pressed, the right mouse button is pressed, the text becomes right, otherwise it's the default, which is press me. And a giveaway of the fact that you're using imperative style, not declarative style, is the equals sign. So most all of the places where the equal sign is actually used is inside the JavaScript blocks for side effects. So in here, this is a JavaScript closure, which is then a JavaScript function, anonymous one, which is then assigned to the onPressed property event, or the event implementation. And what it does is that inside of this block, it changes the color of the parent to green. So this is an assignment, whereas this is a property binding. Okay, so property bindings are good because they are declarative. The QML forms editor in Qt Creator will like you if you use properties and bindings, whereas it gave a warning when I had imperative source code. And then it's better if the actual values of the properties of a QML object are defined as children of that object in the QML source code file. So in here, in a very distant place, in another QML item, we're touching the color of this QML object. Whereas for this QML object, all of its properties come inside of the curly brackets block. So there might be places where you have huge QML files, or maybe functionality split across more than one QML file. Maybe you have also JS, JavaScript files, and then you define your text QML element here, and then in some very distant place, you actually change its color sometimes, and sometimes you change the color back. So this is more centralized, more easy to see all of the side effects that can affect this QML object versus hiding hidden side effects of over the properties of this QML object via imperative source code. Okay, and we're still going to split the business logic in C++, not in JavaScript. So then it's advantageous again to move most of the imperative source code maybe in C++, or in this case, if it's so simple, into a property binding. Okay, let's look at more documentation about the MouseArea QML type. So inherits from item, which means it has X and Y and anchors and width and height. And it adds the pressed, which we've used before. So this public property, this property. Then MouseArea pressed buttons, we've used this also. Turns a enum byte bit flag enum with the 3 possible mouse buttons, which is cute left, cute right, cute middle button. Okay, this is support for drag and drop. You might have an application that has drag and drop support. Cursors. We've used accepted buttons to accept all of the buttons in here. You can disable it. Okay, and the events, the signals are mouse wheel. We've used released. So it says that the corresponding handler is on where are you? On released or released, which we did here. And for wheel there's on wheel, for pressed there's on pressed, which we used previously, or we're using it here. And then there's clicked and on click. On clicked. Where are you? This clicked mouse event mouse. implement the corresponding handler for the event for the signal is onClicked. Okay, most events for clicking have a accepted. Flickable. So if you canceled the click, maybe by pressing the escape key, another item stole the mouse event handling. Okay, I don't know what this thing is. So we have clicked, we have double clicked, entered, and exited, which is what? When the mouse enters without actually you touching the mouse buttons. The mouse exits. There's press and hold for long presses. So sometimes you only have the one button on your mouse, and you might choose to simulate a mouse right button action, such as a context menu, when the event press and hold happens. Okay. And then there's the position of the mouse. So this event has a parameter of type mouse event, which includes the X and Y position and any buttons recently pressed. So this is the parameter type X and Y real. Okay, then the mouse area has the property hover enabled, which by default is false, which means that the events, so this is what it says, that if hover enabled is true, then the signal is events for on entered, on exited, on position changed, and the property contains mouse will be enabled, will do something. But by default, they do not do anything because hover enabled is set to false, and the only events that are triggered are events caused by the three buttons of the mouse. So left, middle, and right, or long button press or double click. Okay, so let's look at the onPressed function, which is for the pressed signal. There is a parameter of type mouse event named mouse. The name is important. And one such member of mouse event is the accepted property. Let's look at that. Setting accepted to true prevents the mouse from being propagated to items below this item. So this is true by default for on press left mouse click buttons. And if you have, for instance, two mouse areas, one on top of the other, overlapping somewhat, then the topmost in Z order will receive the mouse left mouse button click event, and that event will not propagate to the second mouse area that's below in Z order. So just the topmost will receive this mouse click event because accepted is by default true. So you will need to set accepted to be false. And in this case, the mouse area below, the next mouse area below, this mouse area will actually receive the event that the left mouse button was clicked. And this proper and setting accepted to false usually also makes it such that you need to set mouse area property propagate composed events to true. The default value of this is false. And this is because you want events such as control click, press and hold, etc. to be able to propagate to the other mouse areas which are lower in the visual stacking order. And now an important warning is that when you assign to a property, for instance, in imperative source code in QML, then the previous value of that property, which might be an important binding, will be removed. So if you have a rectangle and a property being set there, I know, x equals parent dot x, and then on an event handler, for instance, you set x equals 7, parent dot x plus 7. Let's just say 7. Okay. So as I've said previously, x is the coordinate on the OX axis of the rectangle relative to its parent QML visible item, and this is a binding. Does not matter what the value of the binding is, but any property has an instantaneous value that you can ask the instance of the rectangle, what's your instantaneous value of x, and it will reply. You can find out that information most easily using GammaRay, and then there's the value that was assigned or bound to the property x. In this case is parent.x. But then when later in imperative code, such as in event handlers, you assign something to the same property, then this property is now hard-coded to be 70, and the binding is lost. And from then on, the instantaneous value of the property x will always be 70. So this is a big problem, especially when you want to reuse a custom control and you don't want the users of that custom control to be able to change bindings that make the custom control actually function correctly. That's why you have, when you declare properties, the read-only keyword. So if you have a touchscreen, such as on a smartphone or on a tablet, the QML engine and renderer will actually convert a event of type single finger touched the monitor to a mouse area, mouse button, left mouse button click event. So that's the default event that mouse areas handle. Next up, there's gestures, which you can perform either if you have a touchscreen using your fingers, and there's default emulation with the mouse for desktop. Okay, the first such gesture is flick. So flicking means having a large UI content, having a small window through which you can look at that large content, and then using a flick. So you, for instance, with a mouse, you left click and then drag and then release. You, as it were, scroll the small view such that you can see various parts of the larger reality that's behind this 400 by 400 pixel window. For that, we have a special QML type, which is called Flickable, which provides a surface that can be flicked. Place its children on a surface that can be dragged and flicked. So, in fact, we scroll the bigger reality through a smaller window. Let's see how it looks like. So I have created a 1000 by 1000 image, which is a PNG, which is this thing, which I'm loading inside of an image. So image source, the name of the file in the current directory. We have the small window and the large reality. The reality is 1000 by 1000. The small window is 400 by 400. We need the QML type Flickable in order to have the mouse functionality in my case, because I don't have a touch screen. And then these things are not really needed because I made the image be exactly 1000 by 1000, which is the size of the reality. But if the image is different, then you can use bindings for the image's width and height properties. Okay, so this is the small window. Since it's the top level QML object in my QML file, I can actually resize because the top level item has the width and the height of the XE11 window. Okay, but we're not for that. That's not why we created this application. What we wanted to do is to scroll 2D, so either left to right or top to bottom, by dragging with the left mouse button. And there's a bit of bounce back, infinite scrolling style. Okay, so let's actually look at this application with GammaRay. Let's start it. GammaRay, attach to it this thing, and what happens is that we already know some of the objects in the quick scenes tab in GammaRay. We know that the QQuick root item, so the QML type name slash and Qt style QQuick root item C++ name actually represents the X11 window. And then inside there's the top level QML object that we specify in x-expressions.qml, which is this Flickable with ID Flick. But then we specify just two QML objects in x-expressions.qml, which is our QML source code file, just Flickable and image, whereas 4 objects are actually created. So we specify just this, which is the image, which is the 4th object in the real hierarchy, and Flick, which is actually the 2nd object in the real hierarchy. Why this happens is because the Flickable has a child automatically, which is of type item. So the QML object Flickable always has a child, even if we do not specify one, which is of type QML item. Does not have a name or an ID. Okay, and we need to remember this object hierarchy if we want to use the keyword parent. So for instance, if we want to use width and height not of the image but of the content width of the Flickable, which might be, I don't know, 3000. This thing actually works, so we can specify that the property height of the object image is Flick, which is a valid ID of this object, and then content height. But then we cannot go parent. Let's see if we can actually, if we actually can. Well, it seems that we can. What about if we want width? So the image Where are you? So this is the real parent width. It's 3000. Now the image has the size that we want, which is 3000 by 3000. If we go parent.width and parent.height. But if we go parent.content width and content height, now we have a much smaller resolution. So parent.width is totally not flick.width, not 400, but this 3000 by 3000. Okay, let's see again. So the item has one parent, which is of type item, which is 3000 by 3000, width 3000 and height 3000. And does not have any property content width and content height. So those are probably, I don't know, null, and then the width and height of the image are preserved, which is 1000 by 1000. It's strange that it didn't show any errors. Okay, so do remember that between Flickable and its first child, as it were in the QML, there's an intermediary, which is this item, and this item has the height and width that you specify using content width and content height. Okay, so this is an example of the next gesture. So the first one was flickable, and now we have pinch, which is two-finger zooming on smartphones. So if you touch the touchscreen using two fingers at the same time, and then without removing your fingers from the screen, you close the distance between the two fingers, the image will become smaller. And if you increase the distance between the two fingers without removing the fingers from the screen, then the image will become larger. Okay, since I do not have a touch screen and a second mouse, so I do not have a touchscreen, I cannot actually zoom in and out using PinchArea. Okay, let's look at the documentation a bit. So click on the PinchArea F1, simple pinch gesture handling. Pinch target is the IMG, which IMG is the ID of the image. That's what we actually want to zoom in and out. There's events on pinch started, on pinch updated, on pinch finished. When you remove the two fingers from your screen, on pinch finished. On pinch started, when you have touched with two fingers the screen and begin to move. And then maximum and minimum scale. Reals between 0 and 1. Not really. You can scale more than 100%. and the drag axis. Where is the drag axis? Pinch x-axis, which means dragging can be done horizontally. This is dragging 2D, two-dimensional, and this is dragging just on the y-axis, so vertical. Okay, don't forget to make the PinchArea field its parent, similar to a MouseArea, the PinchArea. Okay, and the gesture, if you want to create your custom gestures, you can use the QML type MultiPointTouchArea. MultiPointTouchArea. How do we comment? I don't know. Let's look at the help. So MultiPointTouchArea. You can have gestures that are something else than pinch and click, so drag, and other than the MouseArea's click and hold. Maximum touch points and the minimum touch points, anchor field parent, and then you have touch points, which is a list of touch point. So this is the property named touch points, which is an array, JSON style with square parentheses, and then touch point 1 and 2. They both have IDs. And then you have bindings with point1.x and point1.y. Let's actually look at this thing. But I do not have a touch screen. So green is the left mouse button pressed, so and drag, which is very similar or correlated or emulated as being a one finger touch on a touchscreen. So that's why we have the green rectangle moving around, but the yellow rectangle is not moving, because I cannot generate using my mouse an event that emulates a second finger touching a touchscreen. And now we're forward in this tutorial at the keyboard interaction chapter. So it says that the input that you generate by pressing keys on your keyboard is sent to your QML application, and you might have a QML object of type text input. That's a single line edit box, and then there's another QML type which is text edit, which is a multi-line edit box, and then you can navigate between elements, so you can change the focused element, for instance, by pressing tab and shift tab. Shift tab is actually called back tab here. Or you might implement directional arrow keys, so a D-pad, a remote control, left, right, top, up and down keys to be used to navigate from one graphical user interface control to the next. Okay, let's look at this example where we have two QML GUI controls that can receive mouse focus, two single line edit boxes, so to edit text inputs. Let's see where the focus is by default. Start. So the focus, we can see the cursor of type text, which is blinking on at the end of the first text input. Okay, and we can navigate to the second text input using the tab key and shift tab. Okay. Focus through. Let's run this thing now. So without active focus on tab, you cannot actually change the focus QML GUI control using the keyboard, for what I can tell. So tab and shift tab do not work. The arrow up and down key do not work. So the only way to change which text input has the cursor is by clicking with the mouse. Okay. By default, no, the focus is outside of the text inputs. Let's look at the focus property. So focus property is a property of the most basic QML type, which is called item. So all QML types probably can be focused. Okay, now if we run it, focus is by default on the probably the first QML GUI control that's created and has focus through. Let's see if that's the case. Just the second text input requires that it has focus. So it receives focus. If both text inputs require that they get focus, the first GUI control that's created actually receives the focus. So focus means I want focus, whereas active focus is the true or false, a property of the QML item. This thing. Read-only property indicates whether the item has real active focus or not. If you press keys on your keyboard, in which of the text inputs will that text be visible? Alright, so we just start it and start the application. The keys that we've pressed on the keyboard are sent to the first text input QML object, because it has both focus, so it wants to have focus, and it also has actual active focus. An item and its enclosing focus scope object. Okay, and with active focus on tab, we tell it that you can use the tab key and shift tab on a desktop computer to change the active focus from the first text input to the second one. So this is a tab, and it once it reaches the last item in tab order, it jumps back to the first item in the tab order. So it wraps. And shift tab goes in the reverse direction. So there's a tab focus chain. Default is set to false, and active focus on tab is also a member of the QML type item. Traverses elements by first visiting the parent and then its children in the order they occur in the children property. Pressing the tab key on an item in the tab focus chain will move keyboard focus to the next in the chain. Back tab, which is normally mapped to shift tab, will move focus to the previous item. If that's not enough for you, you have the option of key navigation. Okay, so now let's look at this key navigation QML type, which is used to have richer ways of and more custom ways of navigating between GUI controls. So we saw the way of navigating between GUI controls using tab and shift tab. But now additionally we also have left, down, right, and up, in addition to tab and back tab. Okay, so this is something which we did not see before, which is called a grid, which has two columns, and there's 4 rectangles, one in each cell, so there's 2 rows and 2 columns. Okay, and then each rectangle has a ID. They're laid out in the intuitive order. So the first one is top left, then top right, and bottom left, and then bottom right. We did not specify how many rows there are. If we add more rectangles, probably more rows will be added. So it's just this, the bottom row, and this, the top row. And 4 cells, one for each rectangle. Let's see how it looks like. So light gray means that the rectangle does not have active focus. And it requests focus. So just one rectangle requests focus, which is the top left one. And this rectangle actually gets the focus. And then we change the focus to one of the other 3 rectangles. So there's top left, top right, and bottom left, 4 rectangles. And I navigate between them using the arrow keys. So arrow key down, arrow key right, arrow key up. And this is done by using the attached property KeyNavigation. And the left, down, right, and up attached properties. Okay, now what are attached properties? So most of the properties that we saw until now started with a lowercase letter, so they use what I call camel case, whereas these start with an upper key, uppercase letter, so this uppercase K, which is what I call Pascal casing. So camel casing, Pascal casing, just a single difference. If the first character is uppercase or lowercase. In Pascal casing, it's uppercase. In camel case is lowercase. So we use camel case, for instance, for method, so function names in C++ and Qt, and Pascal casing with uppercase initial character for the types in Qt. Okay. This is a property. This is a property, but this is a property of this object. So we can do it like this. Expected a qualified name ID. Okay, so this is a property of the current object, whereas this one is kind of like another set of properties that are still applied to this object, but via an intermediary which is similar to a static something. What? So the idea is it was that once you define a QML type, you will only provide for that type the expected properties and events, but then and the signals. But then in time you might add additional properties and signals, which are going to be called attached properties and attached signal handlers to an object, but which are not defined in the QtQuick C++ class that backs the QML type, but in some other place, maybe in another library, certainly in a different C++ Qt type. So additional features that you may want to add to a QML type. And one of such is keys. So there's keys.enabled, which is an attached property, and then keys.onReturnPressed, which is an attached signal handler. So sort of aftermarket features for a QML type. Okay. Okay, so the keys KeyNavigation attached properties provide support for the 4 arrow keys, back a tab, which is probably Shift Tab and Tab. But we have support for more keys using the keys attached properties. So let's actually use those. So we have a rectangle, and inside we have an image, and let's implement attached event handlers. So keys, remember uppercase K, and we have mouse presses on left pressed. Can go img dot rotation equals img dot rotation minus 10. So rotation is in degrees, maximum 360. And let's do the same thing for the other direction. Right plus go. So we need focus. Okay, so left pressed, that's not the left mouse click, it's actually the left arrow key on the keyboard. Okay, so we rotate backwards, counterclockwise, 10 degrees out of 360 at a time. And now I'm pressing the right arrow key on the keyboard. Okay, so we could use any other possible key. There's back tab, there's cancel, which is the red button on Nokia phones. There's flip, which probably is for flip phones. Hang up, which is the red button on Nokia phones. Menu pressed. There were phones that had a hardware button for showing the menu. Escape, return, and enter. Down is the down arrow key. Space, volume up, yes. And the digits. Asterisk pressed. Let's see how that works. Asterisk pressed and on space pressed. Okay, there isn't support for all of the keys. For that you use on pressed. And then you look at the proper at the argument which is named event. Okay, which is this signal. So let's see, asterisk and space. Space, it does work. Asterisk does work. Okay. Okay, so there's keys. We have events or signals for some of the common keys that existed on phones before the event of screen-only smartphones. And then there's the rest signal. In here we can handle, using a syntax like this one, any key. So let's see how this thing looks like. Control C, Control V. So keys on pressed, event, event key, queued key left, and then we'll do this thing. Okay, what does event accepted do? If a key is handled, event.accepted should be set to true to prevent the event propagation up the item hierarchy. So let's just replace this one then. Okay. So we have the left arrow key, and asterisk. So left arrow key and asterisk. Okay. Then let's look at where is the list with all of the possible keys on my keyboard. It's an enum, queued, and then colon colon, and then key underscore something. Which is for C++, not for QML. But the names are the same. Okay. So queued dot, not queued colon colon. This is the C++ syntax. This is the QML syntax. And then there's escape, tab, backspace, return, enter. Insert, delete, pause, print, sys, rec. So most of the keys on the 105 keys keyboard are in here. If there's even sys, rec, if even this key exists, then the other ones are probably there. Home and left up, so the arrow keys. Page up, down, home and end. Okay, insert, delete. The keys used for key combinations, Shift, Control, Meta, Alt. And Meta is actually the Windows key. Alt GR, which is the second Alt on some keyboard layouts. Caps lock, number lock, scroll lock, the function keys, and more than 12, 35 of them. Super left, super right, hyper left, hyper right. I'm not sure what these two do or these two. Menu is probably the Shift F10 key on the Windows keyboards. That shows the context menu. I do not have a help key. Space, yes. Any is another name for space. Exclamation, double quote, parenthesis, asterisk, 0 through 9, colon, semicolon, A to Z. There's no lowercase, uppercase distinction for A to Z keys. Underscore bar, tilde. Kanji. media keys, volume up, down, mute, back, forward, stop, eject for macOS probably, power off, wake up for those interesting keyboards at the start of the 2000s. Okay, so most of the keys, and you also have key combinations with modifiers. Let's look at the material that accompanies the YouTube video series Introduction Tutorial to Qt QML from KDAB. So the videos are in a playlist. Where is the playlist? Introduction to Qt QML, all videos so far. So these are the 54 YouTube videos. Okay. And let's look at the first one. It has the description where it says that the example code showcased in this video is available here, github.com/kdab/kdabtv. Okay. Let's look at the Git repository, so KDAB in github.com/kdab. It has a readme, which is similar to what we saw in the playlist description and in the YouTube video description. Says that it contains the source code of the examples showcased in the KDAB TV video series, which are available on YouTube. Okay, let's actually look at what the source code examples are for this YouTube video series. So not Qt list, not Qt embedding, not Qt widgets, not styling, not Quesa, but QML intro. And then based on just the names of the directories, it's really hard for me to decide this directory to which minute in the video corresponds, or to which video in the video series. So for that, I'm going to download all of the source code. So clone the HTTPS URL. Let's go to the today's date. Okay, and let's git clone here. Okay. So next up, we are going to look at defining custom controls in a QML programming language. So that is done using the component QML type and using two QML files. And one of the QML files is the main.qml file, which is the entry point of the application. The other one has a special name in Pascal casing. In this case, it's called line edit, so uppercase L, uppercase E.qml. And the body, the content of that QML file, becomes the content of a QML type named line edit. With, again, Pascal casing, uppercase L and uppercase E. So let's find that thing. Control S. Line edit. Not loader, not custom property. Line edit, this one. Double click on it. So yeah, it's what we expected. It's a QML project file and a main.qml file, which uses line edit, which is a type that's defined here. So nowhere inside the body of the file lineEdit.qml says that you cannot find the string line edit in here. It's just the name of the file, which is used in coding by convention to define the name of the new QML type. Okay. And in fact, that line edit is represented by a rectangle plus a text input, which a text input is a single line text edit. So used for inputting text using the keyboard. Okay. Let's copy this thing. Control V and open it in Qt Creator, the ID. So file, close all projects and editors. And then open the QML project. Escape to close the help. Okay, so it says project, so we can see that x minus line edit.qml project file was loaded. It says that the current directory is the source for QML files, JavaScript files, image files, and the entry point, the main QML file, is named main.qml. Okay, which looks like this. Contains a rectangle and then a line edit. Let's go to the definition of line edit. So I pressed Control click on line edit, line 17, and it navigated to the other file, which is lineedit.qml. Okay, so let's look at the two files. So again, main.qml defines a rectangle, which is how we usually in this tutorial have created a X11 window. So this will create actually two QML controllers, a root type and a rectangle. Both will be width 400, height 100. So that's the start size. That's also going to be the size of the X11 window. And then as you resize the window, the instantaneous size, width and height of the rectangle will change. Okay. And this color that has been used before, light blue, as the background color for the rectangle. And then inside we have, instead of putting all of this source code, so it was 400, 100, light blue, line edit, anchor, center in parent, with 300, height 50. Okay, let's see how it looks like. Okay, so this is called inlining. And inlining is the opposite of extract to file. So we start with a single QML file main.qml, which is long, contains many source code lines. And then we do a refactoring that's called extract to file. So we move all of these things into a new file. The name of the file is really important again because it defines the name of the QML type. And then these two parts are actually not for the rectangle, but for the control. Okay, let's see that so a refactoring means keeping the existing functionality intact and moving source code lines around. Okay, so we moved some source code lines from main.qml to a totally new file, line80.qml. The functionality is identical. The graphical user interface looks the same, behaves the same, so nothing's really changed from the point of view of the end user. But from the point of view of the developer, of the programmer, some source code lines have moved around. Okay. What are the advantages? Well, the advantage is that this is the soft layer and this is the hard layer. These two files will be changed with different speeds and in different weeks. This will tend to be more stable in time once you finish improving your custom control of type line edit. Then there's no more reason to actually change the source code in line8.qml. So this becomes part of your library of your own library of tools that you use, maybe in more than one QML application. Okay, if you want to create 5 identical line edits with the same style, the same functionality, you just instantiate it as many times as you need. So this is center in parent. So what do we want? We actually want horizontal center. Yeah, like this. Okay, and different y's. So this y is, I don't know, 10. This y is 20. And this y is 30. Shift delete, Control S, run. Okay. The y is wrong, so we'll fix the y. So it says height 50, which means that we need at least 400. And then 50 plus, I don't know, 25, that's 75. Let's make this 100. How about 0? 100 and 200. Okay, so 0 is too little. 20. Okay, so instead of having a huge main.qml file, which let's put this under version control such that we can revert fast. Git init here, git GUI. Okay, commit. I don't have a name. Let's fix that. Ctrl Z BG. Git config -- global user.email. Okay. And user name. My name. Ctrl L. Okay. Commit. Let's look at the history. There's just one branch master, just one git commit. Okay. So how about we do the reverse of the refactoring extract to file? How if we do the refactoring inline from file? Again, the functionalities should be kept the same. The application should continue to look like this, should continue to function the same way it does. We'll just move source code lines around. Okay, so this thing, and this thing, and these 3 lines, we put them at the top of the rectangle. Ctrl Shift delete. Shift delete again. Okay, and now format. There is a button that I keep not finding it. It was edit, advanced, and it can format selection. So I need to select. Does not work. Auto indent. Okay, Ctrl S. Let's make sure nothing has changed. Everything's the same functionally and visually. And it is. Okay, so what I did is I just replaced line edit with the actual contents of the line edit.qml file, which is rectangle, border, column, radius, script, text input. And I added the parts that are different for the 3 line edits. So anchors, horizontal, center, parent, width, height, and Y. Okay, so I needed to inline once, twice, and 3 times. Okay. Inline text input 3 times. Commit. And now the history looks like this. There's the initial commit, just 1 line, master branch, the second commit. Okay, let's go back in history to this place. But then this commit will die. So I'll need to create a branch in here. I'll move the master branch back to the first commit. We set master branch to here hard. Okay. Qt Creator sees that the files have changed on the hard disk. The default behavior can be set in edit preferences. We want to reload it, yes to all. Okay, so in short, that's what QML components are when you use external QML files. So you create your QML source code that you like and that you want to reuse in different applications, in different GUI parts of your application, or multiple times in the same window. You extract, you do refactoring extract and move the relevant source code to a new file. You name that file as you would want the QML control to be named, and then you use that QML control everywhere. So this is called DRY. Don't repeat yourself. Let's look at DRY. C2 wiki DRY. So this is the original wiki from the guy that actually invented wikis. Don't repeat yourself. Duplication can lead to maintenance nightmares. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. So my source code tends to become dry in time, not wet. The opposite of dry is wet. Write everything twice. So I extract classes. I do the refactoring extract towards a class in C++ or C#. In QML, you do refactoring to a different file, to a control. Okay. Okay, so let's look at the source code file line edit.qml. So it contains a rectangle. There's a border color, which I'm not sure how we can see. Okay, like that. So there's actually a green border around the rectangle, and the radius is 4. So radius being the fact that the rectangle is rounded at the corners with a radius of 4 pixels, or what is this? Then it says smooth through, which is what? Smooth sampling is performed using linear interpolation, while non-smooth is performed using nearest neighbor. So this is set to true by default. So there's no need for smooth through. And clip through, yes, because we want the text input not to exit outside the rectangle. Okay. So again, if you have a rectangle that's pretty small. You have a text input that does not fill parent, which it does right now. So if it fills parent, then there's no need to clip. But if you let the text input, for instance, have the width of the text that's inside of it, the string, then the text input will be, in this example, twice as large as the rectangle, and the text input will be painted outside of the rectangle. That's why it's useful to clip. And GUI controls you would expect to have clip true by default. Okay, so there's a rectangle. The only reason for the rectangle to exist is for the border, which is green and has a radius of 4. So to have a green rounded rectangle around it. And then it also sets the background color of the text input, because the rectangle has the property color, which is actually the color with which the rectangle is filled. So because text input is transparent, this color white of the rectangle will actually be the background color of the text input. Okay, and then this text and input is not in the correct Y position relative to the rectangle, so should be more to the bottom of the rectangle, should be, I don't know, centered vertically. And the property text of the property color of the text input is actually the foreground color, so the color of the text, the characters. And if the text input has focus, then it's black. So if active focus is on this text input, the color of the characters is black, otherwise it's gray. And there's also this scaling where the size of the fonts depends on the size of the rectangle. So it's parent dot height minus 4. And there's also margins of 2. Okay. So this is about it for the line edit. Main.qml just uses the line edit, and it sets additional properties such that the line edit is placed in the correct place. The line edit has no height defined, no width defined. So that's why we give the line edit a width and a height. We might have different line edits used, or different line edit instances, different objects of type line edit of different sizes. So we can go height, this one 100, and width 350. Okay. Let's look at the application using GammaRay. Okay, so root item is the parent of rectangle. Then there's a rectangle. Then there's this on-the-fly created type with the strange name, so line edit underscore QML type 0. So this tells us that there's a line edit.qml file somewhere, which it is, that the QML type was actually declared inside of QML source code, not in C++, with this uppercase QML type. And then inside, I'm not sure why there's no rectangle. And then there's a text input. So I can see this instance of the text input. And then this rectangle is named type line edit QML type 0, not type rectangle. So it says it's of type item, it's of type rectangle. So it might be a derived, so a type that's derived from rectangle, this line edit QML type 0. So inherits line edit underscore QML type underscore 0, probably, I'm guessing, inherits from rectangle. So the rectangle color is white. And only rectangles have radius. So it inherits the type rectangle, and it's such that it inherits all of the properties. So it therefore also inherits the type item, which is the base type in QML. Okay. So radius 4 here. Smooth is the default value. Clip is true. Color, we have seen it's FFFF, which is white non-transparent. Border color, the border is a Q quick pen. Okay. Okay, now it says that these are two QML elements. This is the parent and this is the child. And in here in main.qml, this line edit is that type which is defined in QML, which inherits from rectangle and item. And inside line edit, we have access to all of the properties that we saw in GammaRay for the type that inherits from rectangle. So we have a radius, and let's see if we have the radius. Then, yes, it's more rounded. What we have access to is the properties, that means including signal implementations, so signal handlers, of the top object, the top level object inside the line edit.qml file. So we have access to all of the properties of the rectangles. We can create new event handlers if you want, but then we totally have zero access to the text input. So if we want to expose all of the properties of the rectangle, which we already get for free, and we additionally want to expose properties from the text input, then we will need to create custom properties at this level, at the top level, which will be bound to the properties of the text input object. Okay, let's look at the syntax of the property. So how do you create a custom property? So that's the keyword property, then followed by the type, which is string, then the name of the property, then colon. So we either assign it a value, in this case a literal, or we can bind it. So property int area is width times height. Okay, so in Kate I went settings, where are you? Tools, highlighting, sources, and then at letter Q, where are you? Scripts. At letter Q I selected QML. So from the main menu of Kate, tools, highlighting, scripts, QML, such that I have syntax highlighting for the QML programming language. Okay, and the syntax is like this. Read only is optional, and then property is the mandatory keyword, then type could be real, bool, URL, int, string, so QML types, then the name of the property, then you can assign or bind a value like this. Okay. Okay, so some QML types, string, int, real, bool, or URL. And we use the read-only keyword in order to protect bindings. So if a property is bound, so has a binding, we don't want that the users, the consumers of the custom control are able to replace the right-hand side of the property area, I don't know, with 7. It will make no sense. Area is bound to width times height in order to be correct mathematically all of the time. So by using the read-only keyword, we say that the right-hand side of this property cannot be changed. Do you have access to this property? Would you be able to change the right-hand side if the read-only was not there? Maybe you did before, but now, since the read-only keyword is put on the property, there's no way to change the binding of the area anymore. The area will have a integer instantaneous value, but the binding will stay the same. Okay, now we go to the next sample source code, which is called x minus custom minus property, which is this directory. I've copied out this directory outside of the git clone directory such that I can freely edit it. Then in Qt Creator, File, close all files and editors, and I'm drag and dropping the QML project. Okay, so line edit again is stable in time, will change less often, just for important bug fixes or styling, whereas main.qml will vary at different times than when the source code of the lineedit.qml file changes. And again, we can use the line edit in more than one QML file and in more than one project. Okay, so the line edit stayed the same, just a rounded rectangle and then a text. But additionally, because from main.qml we only have access to the properties of the top level element in lineedit.qml, which is the rectangle, we also wanted to be able to access the string that the user has entered in the edit box in the text input. We cannot, by default, go to the rectangle and then to its child and then to the property text. So for that we needed to give the text input an ID, text input, with a lowercase t, and expose via a binding the text property of the text input as the property named text on the rectangle. So rectangles do not have a property named text by default. This is a custom property that we have created. Okay, we have respected the syntax for properties, which is property string, then name, then colon, and then a binding, like this. And line edit text is used in main.qml. So we have a text, which is a label, read-only text, which says that its text is bold summary colon close the boldness, then space, and then this string concatenated with line edit, which is this ID. So it's an instance of the custom control of type line edit, and then its public property text, which we just saw being defined and being custom, this custom property. Let's see how this thing looks like. Okay, so if we enter text, Control A, we can see that the label, which is bold summary colon space and then the text of the instance of line edit, is correct. So the public property text in the line edit works correctly. The text that the user has entered using the keyboard is available outside of the line edit for the label for the text to use. Okay. And then there's the image ID clear button with the missing SVG. So let's put its SVG there. So parent images. Parent image. Okay, this thing Control C. Control V. Let's start the example again. Okay, so to the right hand side of the line edit, there's an image which looks like a button, which has an SVG, clear.svg, which again looks like a button, and has a mouse area which anchors field parent, so the entirety of the image is covered by a mouse area. On clicked, it goes line edit.text is the empty string. Okay. So what this thing actually does, this event handler, so this is imperative because it contains imperative source code because it contains an equal sign. This is actually a JavaScript function. This is actually a JavaScript closure, which is a sign, and this is actually a property. So a event handler, a signal implementation, signal handler. Okay, and it says like this: find me an object with a QML object with the ID line edit, and it found this one. Does it have a property named text? Yes, it has. I don't care what binding it has. From now on, it will have the binding empty string. So this thing actually now is like this. At runtime, it has changed the binding that was created at load time at when we wrote the source code of the QML, which is something that we never want. We never want that client code that uses our custom control is able to change the bindings that we're using for the custom properties, because those bindings, if messed up with, the properties will not work as expected anymore. So if you mess with area, which is width times height, and make it width times width, so the square of width, that's totally not an area. That's a public property that has a documentation and does not deliver on its documentation, so does not respect its documentation. Like this, actually. So not the equal sign when we define a property, but the colon, but then the new value, so it's bound to the literal empty string. Okay, and that's why also the text of the text input did not change. So it says text and then enter text. So maybe we expected that if we set this property, this thing is also set, so this thing is also set. So if you make this thing the empty string, also this becomes the empty string, which is a reasonable thing to ask. If we have a custom control that has an edit box, why wouldn't we want to give the client, the user of our control, the ability to set the text to be displayed in the text box? Okay, so this is just a label that presents the final result, line edit.text. And then we have the line edit and the placeholder, which is the text, enter text. Let's go back to edit mode. From the exterior, if we overwrite this, the text that's displayed inside the text input will not change. So how we can do that? Well, we'll move the placeholder from here to here. And this text will actually be bound to the parent dot text. So text input text is bound to parent dot text, and the rectangle property string text is enter text. Let's see where we are now. So if we edit the text, so it doesn't work as expected. The button to clear is not re-enabled because the image thinks that the line edit.text is empty, so it is semi-transparent, as it were disabled. And that's true because when I clicked on the clear button, it overwrote the property that was not read-only in here. So line edit.text is the empty string now, and no longer the empty string. But then the text. So the problem is that this is the initial binding of the property text of the text input. It's parent.text, which is this. But then the user using the keyboard, when the user types inside of the text input, then the value of the property, the instantaneous value of the property changes. In this case, it's clear, an uppercase C, and that overwrites the binding. So now text is defined as this. And for this, we have property aliases. So it should be text enter text. And this is property alias text. Okay. So property alias text and bound to text input dot text. Okay, let's close the extra running applications. Run it again. So this is the placeholder text. The user has not entered text in the text input. The value of the text is, in this case, the string 1. This value instantaneously is 1. This is property alias, so now the rectangle text or the line edit text property has the instantaneous value of 1. And the summary label is updated correctly. and line edit.text is 1, so is different than 0, so opacity is 1, which means not transparent at all. So the button, clear button, does not appear to be disabled. And now for the grand finale, let's see if this interactive source code line does something wrong. So now it made line edit.text is the empty string, which means this is now the empty string. This is now the empty string. And back, this is the empty string. This is the empty string. We can see it in summary. There's nothing after the colon and the space. This is the empty string, so opacity is 25%. And then if you write something new, everything works correctly. Okay, so this is actually the way to expose properties that are not of the top level element. So the properties of the top level element are exposed by default to the consumers of the custom control. In order to expose properties from the not top level control, so for in this case the text input, you use property alias text and then you have a binding. And just property without read-only or alias. This would be for if you want a top level property. So if you want a property that can be accessed from the users of the custom control, and you're not using a binding. So this is a literal, and from the exterior also a literal will be assigned in here. And then the binding is to use this thing as in the right hand side of another property, the top level item or of the not top level items. So on line 15 you will always have a literal, so this diameter has a default value of 8 when it's defined, and then from the exterior you can read this value and set a value. So you can go diameter equals in imperative source code 20, and then the instantaneous value of the diameter is 20, and then whoever wants to use this 20 will use it in the right hand side as a binding, for instance in here. Okay, and let's see if this string actually works. So it's 8, let's make it 32. Okay. Line edit has a public property that we expect to always have a literal assigned. Then that literal will arrive here and can be used as the right hand side for other properties. Okay, so the source of truth is line 15. We use the property in read-only mode in various places. This is the only place where we can actually write to this property. And since it doesn't have any binding by default, nothing is lost if you assign it another literal, for instance, in here. Okay. Then what if we want to control the properties that are exposed by this custom control? Because by now the custom control exposes the top level elements, so the properties of the instance of the rectangle, so all of the properties that are inherited from item, all of the properties that are on the rectangle type, plus 2 extra, property int diameter 8 and property alias text, which is bound to this property. What if you want to have just 3 properties for the entire custom control? Okay, so in order not to expose the properties of the type rectangle, what we can do is we can wrap the entire custom control in another top level element. And the one that has the fewest properties possible is item. Okay. Now we also need this text input. So our line edit custom control, the instance of type line edit, now inherits just from item, not from item and rectangle. It has just the many properties that exist on the QML type item. So the focus, anchors, children, x, y, z, height, width, opacity, scale, rotation, transform, transition, and these methods. But they will not have access to, the users of the line edit will no longer have access to rectangle radius and rectangle border color, rectangle fill color. Okay, so I've changed the top level QML object to be item, not rectangle. I needed to make the rectangle fill the parent because the default size, width and height of a rectangle is 0 by 0 if it's not the if its size is not given by the X11 window, so if it's not also the root item. Okay, let's see how this thing looks like in GammaRay. So this is the line edit QML type. Which only inherits from item. It no longer inherits from rectangle. And then inside there's a rectangle and then there's a text input. So the number of properties on the line edit QML type 0 is different than before because it stopped having the properties from rectangle. Okay, so let's look at the line edit. It doesn't have a radius anymore. It doesn't have a color, okay, because it inherits just from the QML type item. Okay, then how we add functions, custom functions to our custom control. The syntax is function, then the name, then parentheses, a number of parameters, which could also be 0, so 0 or more parameters, and then the body of the function in curly brackets. So in this case, we have this property text input text, which represents what the text input actually displays on the screen and what the keyboard entry actually changes. So if you focus that text input and you edit with your keyboard the text, this property will actually change. This property is also exposed outside of the custom control via a property alias. And we've also exported a function from the line edit QML custom control, which does text input text, so this property, set to the empty string. And then from main.qml, where we had image MouseArea on clicked line edit dot text equals the empty string, we now go line edit dot clear and round parentheses. So a line edit is the ID of an object, which is this thing. Clear needs to be a property that's exposed by the line edit type, and it is in here. And that property must both exist and be of type function, otherwise it's not callable. Okay, so if this property does not exist, does not say anything when we start the application, but then when we actually run line 41 by clicking on the mouse area on clicked, so a runtime error which says the property clears of type of an object of type line edit is not a function. It's not a function, it does not even exist. Okay. And now it works correctly. If this is a property and a property of type function, it calls it and it does what the body of the function does. So this is adding custom methods. And there's a way to also add custom signals to the custom control. Okay, now we have moved to defining custom signals on the custom control. We have another sample source code, which is X custom signal, which has two SVGs, main.qml, and two checkboxes.
So checkbox being a custom control, you can see checkbox.qml and then use in here, and checkbox better.qml, which is another QML type defined in a QML file and used here. Okay, let's actually copy this directory. Open the QML project. Okay, so let's see what the application does. It contains two rectangles. Shift, delete, shift, delete, shift, delete, shift, delete. Okay, let's see how it looks like. So it's an item with width and height. And inside there's two rectangles with color either light blue, the first one, and then we can see that imperatively using imperative source code with equal sign, it changes the color of the rectangle from light blue to red if the checkbox is checked. Whereas the color of the second rectangle is defined using a right-hand side binding, where it says that if the checkbox is checked, then it's red, otherwise it's light blue. Okay. So QML checked becomes red with this ternary operator. Not checked becomes light blue. So this is the declarative way of setting the fill color of the rectangle, whereas this is the imperative way of setting the fill color of the rectangle using a signal implementation, an event implementation. Parameter check value is not declared. Injection of parameters into signal handlers is deprecated. Use JavaScript functions with formal parameters instead. Okay, let's see what the checkbox does. It has a signal checked with the parameter of type boolean named check value. Which signal is what? Is emitted in here on line 49. So goes parent.checked, and then it expects a boolean parameter. And the boolean parameter is a property which is not for external consumption. So it's not a property that the users of this MouseArea have an interest in. It's just a declarative style local variable. So it's a state machine, as it were, with two states, checked and not checked. So a field in C++ and C#. Okay. And the better checkbox uses a ternary binding and does not expose a signal on the top level element of the QML file, whereas this one exposes the signal. So let's look at the checkbox, control-click on it. Takes me to the correct file, checkbox.qml, which has defined a signal with a parameter of type bool, uses the keyword signal, and then if you want to handle this signal, you need to instantiate checkbox, and then you need to implement a property function named onChecked. So there's lowercase on, and then the first character in the name of the signal uppercased, and then the rest of the characters in the name of the signal. So checked versus unchecked. Okay, so the QML engine does this thing where if you have a signal exposed by a custom control, when you instantiate the custom control, if you define a function named on and then checked with an uppercase C, when this signal is emitted, the body of this function will be called. Okay. And the other way is instead it checkbox better exposes the property checked. So property checked, which is false, and then the source of the image reads from the property, and then on clicked writes to the property. MouseArea on clicked event implementation has this function on the right hand side where it goes and change the value, which is a boolean, from false to true. So this is false, not false is true, and now it assigns true to the property. Okay. No need to initialize the property, it's already false by default. So this says that it's better that if you expose properties from your custom control rather than exposing signals, because exposing signals will mean that you will need to define a JavaScript function body that will be called when the signal is emitted, and that will mean imperative source code, versus if you expose a property, then that property can be used in bindings in right hand side of a binding, which would be usable in declarative source code. And in this case, we can see that the color of the rectangle is defined in just one place on line 39, versus in the first rectangle, the color of the rectangle is defined on line 22, 26, and 27. So on 3 source code lines. If the source code file would have been thousands of lines long, not 50 lines long, maybe the distance between this line and this line and this line might be hundreds of lines apart. So it's not easy just by looking at the source code to decide what's the state machine behind the actual color, the fill color of the rectangle. So you should prefer declarative source code for the QML source code rather than imperative. You save the imperative parts as much as possible and do them in C++. Of course, within reason. If imperative source code and small amounts of it is just what's needed, then do use that. And previously, in the previous version of this source code, to the unchecked, we only assigned the body of the function, so the ternary. Now this is deprecated in Qt 6 and says parameter check value is not declared. Well, it is in here, but it's a legacy support. It says injection of parameters into signal handlers is deprecated. Use JavaScript functions with formal parameters instead. So hopefully this is the syntax. This is a anonymous function. This is the list of formal parameters. So it takes just one parameter named check value, and then the body is after the equals greater than. So if I control click on unchecked, it takes me to the definition of the signal. If I control click on the checkbox, it takes me to the checkbox.qml. And it also takes me to the correct place, which is the top level item, so line 14. If I control click on parent, it takes me to rectangle because that's the parent of the checkbox. Checkbox better goes to the correct place. And checked goes to the correct place, which is line 13. Unchecked changed. When you implement a property in QML, the machinery, the QML engine, automatically prepares a backing store field, a observable event, which is this unchecked changed. We have seen when we looked at the help of QML types that for each property there's a corresponding event on that property named changed. I cannot find it in here. Where are the signals? It doesn't say. Okay, so I have put an ID on the item to name it. I've named it top element. The top element is selected, and now I can use the connections tool window. In here I have selected a new connection. In this combo box I have selected top element, so that's the target of the connection. And then I'm selecting which of the signals to handle. This is a combo box, and there's a X property on item, on the QML type item, and associated there's a signal X changed and a signal handler on X changed. So for the property X, there's X changed and on X changed. For Y, for the property Y, there's Y changed on Y changed. For the property Z, there's Z changed on Z changed. For the property visible, there's visible changed on visible changed, etc. For the property scale, there's on scale changed and scale changed. For the property opacity, there's opacity changed and on opacity changed. So most of the properties that have an instantaneous value on the type item, on the type rectangle, etc., have associated a signal with the name of the property and then changed. So opacity property has assigned the signal opacity changed. And then the naming rule for signal handlers is on and then uppercase the first character in the signal name and then the rest of the characters in the signal name. So these changed signals are used in order to propagate when a property setter is called. So when we change the property, we actually call the property setter, and that property setter then informs whoever is interested via the signal property name changed that the property's value has changed. And then that can cascade to many other QML objects if they're interested on the fact that that property has changed. Okay, so if I click on checked changed, it actually takes me to the checked property, which is a custom one, but just writing the text on line 13, so property bool checked :false, automatically defines a signal named checked changed, and then in order to handle that signal, you need to implement the property on checked changed. Okay, without parameters, without arguments. So the next is how to size a custom control. So you define in QML, in a QML file, a custom control, and that custom control must both resize correctly depending on its parent, but also declare to its surrounding, here is the size that I would like. If you do not specify when you instantiate that custom control width and height, then that custom control will have a preferred width and height. So that's X button. Let's open this. So file close all projects and editors. And then the QML project file, open it in QML by drag and drop. Press escape to hide the F1 help. And let's look at a longer source code file, longer than what we saw before. Let's look at the application. This is the way it looks like. And there's a button.qml, which we can see is instantiated once, twice, 3 times, 4 times, 5 times. And the property for the button is set to text cancel. So this is probably that button. Button text OK, this one. Button text test, this one. Button text close and button text open. Okay. Sometimes when instantiated the button, we specify a width. Other time when instantiating the button, we specify just the height. Other times we do not specify neither height nor width. Okay. Now let's read the main.qml file from top to bottom. So we start with the parent, the root element, which is of type item. Then this parent has 3 children, a row, a rectangle, and another row. We can see that when we collapse a QML element in the Qt Creator QML JavaScript text editor, it collapses like this. We can see the type of the QML. So we can see the QML type, and we can see the ID when collapsed. So it says row and ID bottom button row, rectangle ID content, row ID top button row. So whenever possible, it helps if you define an ID, even if that's not really necessary. Even if you comment out this ID, everything works okay. It's advantageous to have IDs on QML objects because that will make it easier when you collapse source code, will make it easier when you inspect in GammaRay. It will make it easier for you when you log. Okay, so you can see it's easier to reason with top button row than to reason with 0x56380 D5 28 D30. Okay. And what do these 3 things do? So this is a row, which is a layout manager in Qt, which is actually this rectangle, the rectangle with a white background. Then there's a rectangle, which is this rectangle with the light blue fill color. And finally, a row, bottom button row is this rectangle with white background. Okay, let's look at the first row. It says its ID. It says anchor stop parent top, so it's the top of the row is glued to the top of the item. And horizontal center. Horizontal means adjust left right, so it's like this. It's parent horizontal center. So this is the way it's centered in the middle of the vertical middle of the item. Okay. So anchor stop, horizontal center, parent center, spacing between QML items 20. And then 2 buttons with the same width, open and close as text. So we did this part of the UI. Now this part of the UI. So this is a rectangle, color light steel blue, is named ID content, anchors, it is glued top, its top is glued to the row's bottom. The bottom is glued to the other row's top. Left and right anchor. And one button and one rectangle. The button is with text test and the rectangle is color red with 50. Okay. The height is the height of the rectangle is the height of the button, and it's 100 hard-coded. The anchors, so anchor left for the red rectangle is content button dot right. So this will always be glued together. And then vertical center, content button, vertical center. That's needed because otherwise the Y of the rectangle would be 0. Like this. If the Y is 0, then they don't really touch. Even though they have the same, this X is both the right extreme of the content button and the left extreme of the rectangle. Okay, let's look at the bottom button row. Is anchored bottom to the parent bottom. Makes sense. So the two rows are anchored to the parent, one to the parent top, the other to the parent bottom. But then the rectangle is anchored top and bottom to the two button rows. So the parent is the item, has a certain size, which size is then resizable because it becomes a root element, so a X11 window. And then this width and height gives the place where the first row is put with top, parent top, and then anchors bottom, parent bottom. The rest of the space is filled up by the rectangle. Let's actually see this thing. So the two rows have a fixed height, whereas the rectangle fills the rest. Okay, but then the row does not specify a height. This bottom row does not specify a height, and the height is still fixed. When the rectangle specifies that its top and bottom is glued to these things with a fixed height, then it's clear that the height of the rectangle will vary when you resize the window. Okay, and then let's see how the button is implemented. So we've seen that the top row has a fixed height. What's that height? That height is, I don't know, implicit height background dot implicit height, which background is a border image which has a source and fills the parent. So if this would be the items property width bound to the background width or height in this case, so height bound to height, then anchors fill bound to parent, then that would be an infinite loop. But in this case it's not, because the item specifies implicit width and height, and the border image specifies fill parent, which means that the actual height of the border image should be the height of the item. Okay, what's a border image? Control click on button, control click on border image, does not work. F1 on border image, opening edit mode. So a border image is used to create something similar to a window decoration. So like this. This would be the top. So number 2. This corner would be number 3. This other corner would be number 1. This would be number 4. And then window decorations, when you resize them, these 1, 3, 7, and 9 do not stretch at all, so remain unchanged. Whereas 2, 6, 8, and 4 have a different size depending on how you resize the window. And there's ways for you to specify how 2, 8, 4, 6, and 5 are resized. Okay, and the image is button.png. I can control click on it, so it looks like this. It's feels concave to me. Control scroll to zoom. Control W to click. As a text, which is a label, as the ID label, anchor center in parent, and font pixel size 30. Okay, so the size of the image is 80 by 72. So 80 width and 72 height. So the 72 height is what we'll see if we'll inspect this application using GammaRay. Let's see. Okay, so this button, let's pick the button, this one with OK. So we can see button QML type 1, 2, 3, 4, 5 times. So we know by this uppercase QML type that there's a file named button with an uppercase b.qml, and there is, where a custom control is defined, and that custom control QML type is instantiated 5 times. None of them has an ID, and then the height should be 72. Let's actually see what it is. So height is 41, the height of the text. Yeah, but the height of the button 72. Okay. So actually the image has an initial height and width, has a size, and that's used for implicit height and width of the image and of the border image. So this border image inherits from item, from image base, and from and is of type border image. So it does not inherit from image. Okay. Okay. So let's look at the implicit width of the button custom QML type. It's the label implicit width. So label has it's of type text and has a text. The text gives it the implicit width, so it's the height, the width that's needed for the text to be shown in its entirety, plus 2 times the margin. Margin is 35, and the button is 72 pixels in height. So that 72 is probably 35 by 35, so this 35 by 35 is the square 1. This 35 by 35 is square 3. This 35 by 35 is square 7. And this 35 by 35 is square 9. So the corners of the window decoration. And then the middle, so 4 and 6 are just 2 pixels high. But they will get stretched, whereas the 2 and 8 are 10 pixels in width. Okay, that's why we have this local variable with a value 32 of type integer. In order to use such a local variable, we use a read-only property, and we can see this naming convention where, because this is not actually a public property, it's just for the internal use of this object. So it acts as a local variable. It has 2 underscores at the start of the identifier name. So 35 is actually 35 by 35 is the size in pixels of the first square in the border image. So this thing, 1, region 1. Okay. So it leaves enough space to put the 1, 4, and 7. Then it puts the label, so the text, and then leaves enough space for the 3, 6, and 9, which is 35 pixels in width. Okay, that's the implicit width of the entire button. The implicit height of the entire button is 72. Just are coded because that's the height of that's the minimum height of the border image. Okay. So again, the height of 3 plus 6 plus 9 is 3 regions, which is 35 plus 35 plus 2, so 72. And you can see it in here that it's 72 pixels high. Okay. There's places where we instantiate the button. We do not specify any width, any height. So the QML engine will ask the button, hey, do you have an implicit width and height? And the button will say, yes, implicit height 72, implicit width 70 plus whatever is necessary for the width of the text. And we can see if we not implement the implicit width and implicit height, because the item is not doesn't have as parent the root, so the X11 window. The item's width and height by default will be 0, and implicit width, implicit height is also 0, although it contains a border image and then contains a text. But then it does not do any clipping, so clip is false on the item and on the border image. So let's look how interesting it looks like. Okay, so the rectangle does have a width of 50, and the height is the content button height, which content button has a height defined in here as 100. So we were able to compute via bindings the value of the rectangle height 100, rectangle width 50, color red. So there's all that's necessary in order for the rectangle to be painted. The rectangle left is anchored to content button dot right, but the content button has width 0 and implicit width 0. But it does have a vertical center because the button is anchors vertical center, parent vertical center, which everything is the rectangle. There's no rows, top button row, there's no bottom row, so the rectangle fills the entirety of the item and of the X11 window with its fill color of light steel blue. Okay, let's inspect this thing in GammaRay. So there's a ton of warnings in the quick scenes object tree. For the top button row, it complains that it has the item is visible but out of view because it has a size of 0. So it's not that it has a size non-zero, but its x is negative and y is negative, and it's shown outside of the X11 window, no. But the item has a width and height of 0, and it's in here. It's the non-existing pixel as at the coordinates 0, 0, x0, y0, width 0, height 0. Okay. Then the same thing for the bottom row. Item has a size of 0. Why do we see these texts in here? How do we move this thing? Pan view, this thing. Okay, there's an OK and a cancel here. Let's select one. So this is the pan tool, which allows you to move by drag and drop. And then there's the pick element. Let's pick the something. We cannot. So on the bottom, there's two labels, one with text OK, T, text OK, this one, and the other one label with text cancel, this one. The warning says item is visible but partially out of view. So the item is partially viewable, visible, because none of its parents do clip equals true. So let's see this. Okay. Does it have clip true? No, it's false. Background, clip false. Button, clip false. Button view, clip false. And the item, clip false. And the slash is clip false. So that's why we see some text, because although the parent of the label has x and y, has width and height 0, the text QML type, QML object, is rendered outside of its parent because the parent doesn't have the property clip with value true. But if we do that, if we change the value of the clip, okay, now we don't have the text OK visible at all. And the same for the other. Background, clip, and now there's no text visible at all. Pan tool, move. Okay, let's revert our change. Button QML, uncomment the lines with implicit width and height. And we're back to where we were. Let's look at the spacing between the button open and close. How is that achieved with this spacing 20 and another spacing 20 for the row on the bottom. Okay, so the button open, this thing, Okay, where is the padding 0? Where is the padding actually applied? On the row. Spacing, not padding, spacing. Spacing 20. Let's make this 200. What does spacing do? F1 is the amount of pixels left empty between adjacent items. And this is for the row. So the row QML type displays its children, so position is a layout manager, and puts its children QML item objects in a row. So the first one that's defined, and then the second one is to the right hand side of the first one, and between them there's this spacing property which tells the QML engine to either stick one item, glue it together, so to glue the two elements, like this. If we make this 0, or to put a bit of distance between them in pixels. Okay. And the row's width is 620, which is less than the width of the root, which is 800. So the row actually has just the width of its implicit width, so just what's needed, not more. Okay, the bottom row again has its width equals to its implicit width, so 293, and width 293, and it's just enough space for the two buttons and for the 20 pixels width in spacing. Okay, what if we comment out the implicit width of the button and leave the implicit height implemented correctly for the button? Then the button in the rectangle has 0 width. The buttons on the button row have 0 pixels height. So the width is specified for the two buttons at the top, and there's an implicit height which becomes a height. So both the width and height for these two buttons can be computed for the button open and close. For the buttons at the bottom, we do not know a height or a width because it's not specified. but they have a implicit height, which is 72, which also becomes the height. So probably the two buttons have height 72 and width 0. Let's actually see that. Where are the actual buttons? This guy. Nowhere to be seen. And this guy. So they have a height, which is 72. They have an implicit height, which is 72. Width and implicit width are both 0. Okay, what's interesting is that you can change at runtime the implicit width, which then automatically becomes the width. Stored and writable. Okay. When we gave it a implicit height, then it had a height. We gave it an implicit width of 100. So now the width is 100. The height is 72. So it can be painted. And that gives the height of the bottom row, which is 72. Where are you, height? This thing. Let's see why by default when we comment out implicit width, the bottom button row has height 0, which is interesting because the button seems to have the correct height, which is 72. Okay, let's open GammaRay. So the bottom row, this thing, bottom row is somewhere there, and the height is 0, and the implicit height is also 0. Button has implicit height 72 and height 72. So how is that? The row does not have any height. It has an implicit height. The button has an implicit height of 72 and a height of 72, but that is not being applied to the QML object of type QML row, which is really interesting. So the row has height 0, but the button has height 72. So the button is not visible, it has height 72 and width 0. That's why we don't see the buttons at the bottom, because they have correct height, wrong width. But still, why doesn't the row have 72 pixels height and not show the buttons inside? if we edit one of the buttons and change its implicit width to anything given to 1, then immediately the button becomes visible, has 72 by 1 pixel, and the row respects the visible child. But if it's or if the row has all of the children with 0, then the children. So the rule of thumb is that all custom controls should specify an implicit width and height. So that's at the root element. You go at the top level element in your custom controls QML file, and there you should make sure that you have implicit width and height, because you do not know the QML source code that actually uses your custom control. Will that specify a width and a height to the instance of your custom control or not? They might not, they might specify just a width or just a height. So exactly as the image has an implicit height and width, the exact same way as the QML type text has an implicit height and width, the same, the custom controls should have an implicit height and width. So if you don't specify when you instantiate a height and a width, those will exist, implicit height and width for the instance. So the QML types themselves should specify an implicit height and width. And then, so that's bottom up at the bottom of the tree of controls using parenting. So when you look at your QML application using GammaRay, you will see a tree of QML object instances. So that tree of objects specifies implicit width and implicit height from the bottom up. And then from the top down, you specify width and height. Maybe you always have a width and a height on the root element, because that's the width and the height of the X11 window. And then that trickles down, and then there's anchors that will give heights and widths to the children of the top level element. Okay, and the last thing that we will do in this part of the tutorial is local variables. Let's look at those. So we have properties that are not accessible from the that might be accessible from the exterior, but they use a naming convention which separates them and makes it obvious that these are not true properties that are designed to be used from outside the rectangle, but instead are local variables that are meant to be used inside of the instance of this object. Okay, so we use the row and the column as it were private property just for reading from it and computing X and Y via a binding. and then for writing to them on event implementations. So let's look at the application. It's a grid, 1, 2, 3, 4 columns, 1, 2, 3, 4 rows, so 16 cells in total. And using keys on left, on right, on down, on up pressed, we change either the column and we increment it, or the row, and we either increment, decrement the column when I go left arrow key on my keyboard, right arrow key on my keyboard, I increment the column. When I go up on arrow on my keyboard, we decrement the row. And when I go down arrow key on my keyboard, we increment the row. So by moving with the arrow keys, I just change the value that's stored in the property of type int __ row, which goes from 0 to 3. And then based on row and column, we compute the actual x and y of the rectangle. Okay, so item size is 80 pixels. So 0 times 80, that's coordinate x 0. 0 times 80, that's a y coordinate 0. For column 0, row 0, so for the cell 0, 0. And for the cell 0, 1, which means first row, second column, the row is 0, column is 1. So x is 1 times 80, 80, and y is 0 times 80, which is 0. Let's actually look at this thing. Okay, so x and y. And now I move down, so down arrow key, which increments the row, keeps the column to 0. And now y is 80. I go right, now both y and x should be 80. So x is now 8 and will become 80. Okay, so we have properties which are used as local variables inside of this scope to be written by event implementation, so signal handlers, and to be read by bindings for other properties. Thank you.